Ladies and gentlemen, welcome back to the F.O.C podcast show, hosted by yours truly, Kyle McLaughlin, and sponsored by Northstar Technologies Group. Thank you as always for joining us on this awesome show. We got a great episode for you today. It is a continuation of the previous episode, which is part one, this being part two of a three-part series for going through the advanced performance of Northstar Technologies and its composite building systems and all of the great things that we do here. So this is a listen along presentation which you will see live on YouTube as well. If you want to see the actual slideshow, you'll be able to not only see it there, Facebook and Instagram, but also download it and use it for your own use. It will be on our website as well. It is chock full of great information, great technical details, great specs on our system, and some good case studies. So that's what I'm working off of today, and this is the second part of that. So let's dive right back in where we left off on the last episode. So just a quick recap, we were going through features and benefits. So we talked about fire resistancy, we talked about the weight to strength ratio, we talked about the hurricane resistance, we talked about energy efficiency, which is huge for us, water resistance, ballistic rating, impact rating, and then obviously mold and corrosion and any degradation. And then how those benefits correlate to building, right? Whether it's residential or commercial construction. There are a host of benefits. Picking up on this next slide here, we're talking about advanced storm safety. So whether you're in Florida, whether you're in Louisiana, New Orleans, whether you're in South Texas, in North Carolina, South Carolina, areas in Georgia that are exposed to high velocity hurricanes, high velocity zones, otherwise known as high velocity hurricane zones, you are going to need some storm safety, right? And a lot of building systems today are made to what's called code minimum. And code minimum is essentially just doing something to the bare, as it sounds, to the extreme bare minimum, just enough to get that passing mark. So I think in school that's considered a C, which is average. And that's not what anybody should strive to be, especially when it comes to building their homes or buildings that they work out of, right? Where they keep their most important materials, where they keep their family, where they keep their businesses. That should not be made to an average standard. That should be made to the absolute best standard that it possibly can be made. And that's a big part of our company mission. That's a big part of our motto, our core values. That's what we do to protect our home, to protect our loved ones, to protect our place of businesses, our government, our school, where our kids go to, spend a lot of time, libraries, all these really important areas that are being built to the absolute minimum should not be, right? Especially when it comes in areas like Florida, where storm safety is such a concern, right? So we have a few things that the system really works well against. So number one being water and wind. We have a full dry seal system that ensures zero permeation by winter water. The impact rating that we've talked about previously, which is obviously up to 250 miles an hour. The entire structure is completely impact resistant, right? And that includes your windows and doors. Everything is storm rated. We use hurricane proof or hurricane standard windows. The same thing with doors and garage doors. Sliders or fixed windows, doesn't matter. From a communication standpoint, this is important when power goes out. Our system is fully RF transparent. So what does RF mean? It's radio frequency. So whether it's Wi-Fi, whether it's radio, whether it's telephone, having a transparent building system allows for streamlined communication, especially when I don't know if you've ever been through a hurricane or through a natural disaster, the phone service tends to go out, right? Or it becomes really limited. So reducing your limitations to that even further by having an RF transparent building is going to be that much more beneficial for you if you're in a situation where you need to communicate, right? Corrosion. We have no corrosion or degradation from water or chemicals, which we've gone over before, but it's important to note, again, during a storm where certain things can flood or have spillage from fuel, from gasoline, from different areas where your home is being exposed to liquids and materials that it's not normally exposed to due to a flood, right? We had a lot of flooding that happened during Ian, and that surge water brought through, unfortunately, sewage. It brought through a certain amount of gasoline and oils and different liquids in the water that normally wouldn't be there. So again, your house being exposed to these materials, it's important that it doesn't degrade, right? Again, mold being a big part of that as well. We saw a lot of the homes that flooded, unfortunately, that immediately got mold infections. So we don't want to have that happen, obviously, to our homes. And you want to have a building system that's going to be resilient towards that or against that. Conductivity is a big one too. It is a non-conductive material as opposed to metal, for example. I talked previous episodes about people building either small footprint homes or tiny homes or barndominiums out of metal. And while that may seem like a good idea from a cost standpoint, it is not a good idea from a store safety standpoint or even just a safety standpoint in general. So consider that when you are looking at building a building out of metal. You're going to have high conductivity and high thermal transfer, meaning that your home or your commercial building won't be as energy efficient if you're making things out of highly conductive materials, right? Makes sense. Fire, up to 1 hour fire resistance for additional protection. That is not something that most building systems can claim. We are currently the only residential building system that has any sort of fire rating associated to it. Most fire ratings, for some odd reason, are only limited to commercial buildings. They don't have fire rating standards for residential buildings, which is strange considering homes is where we have our loved ones, our kids, our pets, our families. Commercial buildings, although equally as important, don't usually house our loved ones, right? So you would think that there would be a fire rating standard for homes. There isn't, so we created one, hence the Northstar Homes fire rating features. If you're looking at this on YouTube or somewhere where you can see my screen, you're going to see a video here, and I'll describe it to those of you that are just listening on the podcast. But you're going to see a video here. This is live footage that I'm playing right now from Hurricane Ian, one of our builds over on 111th Street, which is in the north side of Naples Park, was exposed to peak winds at 185 miles an hour during uh, Hurricane Ian's impact here in Naples, Florida. So normally a builder will protect their existing builds that are in the shell stage. Shell stage meaning that they're in a stage where the windows and the doors haven't been installed yet. They'll do that using plywood normally or some sort of barrier that seals that door or window opening from the outside elements. Reason being that if wind gets in there at a high speed, it could actually blow off the roof or blow off other parts of the home, including areas that are made of wood, right? Normally doesn't happen with concrete too much, more so with wood. But nonetheless, you want to cover that up because it could blow up your floor assemblies, any framing that you have in the interior, and of course your trusses and your roof sheathing. We, as you can see on this video, left that completely exposed, and a lot of that was to put our our money where our mouth is, right? To proof is in the pudding. If we're claiming all of these really high end safety features and benefits that are not common in the building industry, what better way to display it than this, right? So we did not seal any of the door openings. We did not cover any of the window openings. We left it exactly as is, and there was absolutely zero damage to that home during peak winds of 185 miles an hour. And I would challenge any other builder, hopefully, I mean, eventually we'll have another storm, but hopefully not anytime soon, to leave a normal, traditionally built house in this stage of construction exposed and see if anything happens to it. Because undoubtedly something would. But due to the way that we build these homes, the materials that we use, how they're engineered, how they're manufactured, how they're designed, how they come together, how we construct them, nothing happened to this home. And that's an incredible claim. And that's something that we highlight not only on this slide, but a lot of the times when we're educating the public about construction methods and what's most effective and what's more safe, right? And what's going to save you money over the long term, right? Not the short term. It's going to be building a Northstar home. And this is an incredible benefit, an incredible case study to show. And we do have a little footnote there that says we're approved for the construction of emergency management storm shelters. Why is that even a bullet point in here? It's extremely important because during a hurricane, normally there's set evacuation areas, right? Normally it's a school or a government building. They're what's classified as an emergency management storm shelter. That's a term that's used in construction where there's buildings that are built to withstand 185-mile-an-hour winds, right? Or impact rating for that matter. So because we're built up to 250, when you're building a Northstar home, you're purchasing and you're living in an emergency management certified storm shelter, believe it or not. So there's no need for you to evacuate anywhere. And I'm not by any means saying you shouldn't evacuate during the next storm if you're in a Northstar home. Obviously use your better judgment. But from the standpoint of being exposed to impact and wind, you won't have anything to worry about in these homes. We are built to the same, actually, we exceed the standards of these emergency management shelters. And again, they're all built depending on the area and the location and the use of the building. They could be built up to 250 miles an hour too, but they're definitely not exceeding that. So you'll be safe in a Northstar home just as you would in evacuation shelter. The next slide talks about our innovative technologies, right? So it gives you a little bit of an explainer. For those of you that can't see my screen, I'll explain it as best as I can. There's three real steps that we go through when it comes to designing and manufacturing and engineering and eventually building the home, right? A lot of that happens through what I would say three critical channels. The first one being the state-of-the-art software that we use. So we 3D model every single home that we design, engineer, manufacture, and build. Everything starts in a 3D digital environment. And we use a system called SolidWorks. We've also used a system called Revit for those of you guys that are familiar with architectural and engineering software to model these components, to model these homes. And if I ever come in and do a tour, we'll take you by the engineering department, and they're essentially modeling down to the stud and bolt level. They're modeling entire homes, right? So they can take the home that I'm showing on the screen right now, which is a two-story, 3,000 square foot home, scroll in to the most molecular level of the house being a bolt, right, or being a stud, and show you from that starting point out how many different uh, pieces and components of our material go into these houses. They're fully modeled to create what's called a BIM library. And in that library, we basically have an entire Rolodex of all the materials that are in your home specifically, which number one makes precision manufacturing that much more precise, right? Because we know where every stud is going on your home before we've ever even stepped foot on your lot, right? But number two, it gives us a really, really good basis to establish a maintenance manual for the structural components of your house, right? Because if we know that in the future, if there were ever to be a failure, right, that we can identify that quickly because we have a whole library of where the materials went as opposed to just randomly using wood and steel and concrete where it makes the most sense when you're building things, right? So that is a huge component from, again, from a peace of mind standpoint, maintenance standpoint, and from a precision standpoint. Everything is done, to 1/18th of an inch. So it's extremely accurate. Speaking of precision manufacturing, our CNC system integrates the design and engineering aspect into its production. So again, that's where the accuracy really comes into play. And because we're using machines, we can automate a lot of the features through the manufacturing process. So through the use of robotics, which is really where, if I give you like a inside peek on what we're working on for future innovations, it's really through the use of robotics, right? So how can we get the CNC machine to move wall panels or different assemblies or different sections of a structure that we're manufacturing in an automated process that doesn't involve a lot of human labor, right? The human component is more geared towards the engineering and the precision and the management of these machines as opposed to the actual heavy labor of lifting, cutting, milling, and drilling, right? And that's really where we see this evolution of construction heading to. And we're already seeing that in certain segments of the market. I mean, you've probably heard a lot about 3D printing and people printing all sorts of different things, right? But for the case of what I'm talking about, even printing houses, and that is kind of goes in line with what I'm talking about right now. There's a whole nother conversation to be had about the advantages and disadvantages and the feasibility of actually printing a house. But this is about as close as you're going to get while still maintaining that structural and workmanship stability. The next slide talks about our homes in particular. So Northstar Homes is redefining the construction process, as we all know, right? With innovative FRP composite materials delivering unmatched durability and lasting quality. I'm showing a couple pictures of some models that we're actively working on right now with the Lotus on the bottom left-hand corner and some other concepts that we are in the process of engineering right now with the barnuminium and the small footprint home up on the top right-hand corner. Our specialty is crafting custom-built residences that not only offer substantial insurance savings, which I've talked about with the thermal efficiency and the maintenance-free factor, and obviously the safety features that get baked into that whole insurance underwriting, if you will, when these carriers are looking at, should I insure your home and how much is it going to cost you to insure your home? They're going to look at all these factors from a replacement standpoint, from a structural standpoint, and that's really where this comes into play, right? But also it features an expedited build time, and that's important too, from the sake of getting into your home sooner than not. Our energy efficient and virtually maintenance free homes combine the comfort and convenience, ensuring a superior living experience, as I've been talking about. I wanted to show you guys a example of the traditional construction timeline, right? So this is what you would normally be used to if you did things traditionally, right? So a customer would start with an architect. Any local architect or anybody online, and they would say, "Hey, I have an idea of what I want to build. Here's a napkin sketch. Here's a concept. Can you put this into an actual plan?" And again, if you don't know how the process works, a few episodes ago, I did a full-blown uh, explanation of the construction process from A to Z. It was actually also broken out into three different episodes. Episode one covers pre-construction and talks a lot about the architectural part. So I encourage you to go watch that episode if you haven't already. But for the sake of what I'm illustrating here, once you have an initial concept thought of and drawn up, your architect will put together a set of architectural drawings, right? Which will be part of your permit packet, which we'll get to here in a little bit. And that normally, depending on the architect, depending on the complexity of the build, the size of the build, the jurisdiction, where it's located, any lot challenges, feasibility, geography, topography, could take anywhere from, on the short side, 6 weeks, on the long side, or probably more average side, all the way up to 9 to 12 weeks to complete those drawings. After those are completed, your architect will then probably, or yourself, will work with a structural engineer that will make sure that the structure that's being designed is actually buildable, right? And what sort of things are they going to have to look at from a span perspective, from a slider opening perspective, right? From where it sits relative to the flood level, how high does that foundation need to come up? What is the roof design and the roof engineering that needs to be calculated? Any decking or balconies? I mean, there's so much that goes into the engineering process. That's basically the engine that makes sure that you can actually build what you're designing, right? That process can take a little bit as well. Could usually a little bit faster than architecture because on the architecture process, there's more revisions. There's a little bit more back and forth between the customer and the architect. Whereas with the engineering, there's not a lot of back and forth. It's just whether is this feasible, yes or no? How do I engineer to make sure that it can be built? Any revisions needed that would require, a cost consideration from the builder standpoint, obviously need to be revised with the customer. Normally, it's a little bit faster. After that, you have a full set of plans, right? At that point, you can take your plans and have any sort of GC bid that out for you to see how much it would cost to build it. Depending on the builder that you're using, again, the materials, the location, there's a host of variables that go into this process. You're going to get two or three different quotes that are going to vary in price, right? Once you make your determination, you hire your contractor, then your contractor goes out and hires their subcontractors, right? Any work that they're not self-performing, normally that would be your mechanical, your electrical, and your plumbing. They're going to sub that out, and then anything that they perform, which is normally finish work, rough and work, labor, all that is usually done in-house for the most part for most builders. That they won't subcontract out. But from the standpoint of my timeline here, your GC will hire those subcontractors, right? The permitting process is going to take, depending on your jurisdiction, your AHJ, your building authority, if you will, county, city, or any combination of the two, could take a little bit. In our local level here from Collier, Lee County, we're averaging about 6 to 8 weeks, including revisions or including commentary time, where the county will say, "Hey, can you explain this in further detail, or show me a survey for this, or something different that you may be missing from the initial set of construction documents." So all that back and forth included probably about 6 to 8 weeks. As soon as that permit is awarded, your land is officially entitled and you are ready to start hitting shovel the dirt, meaning that the jurisdiction has been giving you full permission to start the construction process. And that's when everybody mobilizes, right? And then construction itself, again, depending on many variables such as the complexity of the build, the size of the build, how many stories, where it's located, the builder that you're using, their subcontractors could take anywhere from 8 to 12 months on average, right? And then after they've acquired CO and you've done your final walkthrough, which we talked about on episode, I believe it was 6 of that podcast that I was talking about, the 3-part series, where we talked about that final CO process and inspections. Um, After that, you're ready for turnover and you get the keys to your home, right? So that total duration, again, minus those variables that I spoke about during the timeline, could be anywhere from 14 to 21 months. And I know that sounds like a long time. It is just a range average depending on the size of the home. A smaller home is obviously not going to take that long. Usually a standard process is about a year. It could move into 2 years if it's a bigger, more complex build, and even more from there, depending on whether it's a more complex commercial job. So now is the example of a Northstar construction timeline, which obviously is expedited for some of the reasons that I talked about earlier. So we are a design builder, so there's no need to go find your own architect. There's no need to find your own engineer. We have structural partners that we work with, some of which are in-house. Um, so essentially, you would hire us. We would start the integrated design and engineering process cohesively, meaning they're happening both at the same time. Our design team integrates and communicates with our structural team to make sure that whatever they're concepting, whatever they're drawing out, whatever is in schematic is actually constructible and fully be able to be engineered and stamped. So that because we consolidate that into one, it significantly expedites that process, right? So as soon as we have those permit ready plans, again, we do the same thing. We apply for permits, and being the GC, we do that for you. But while that permit is being approved, remember that's 6 to 8 week timeline. We're already starting manufacturing, right? We're already starting to build some of the walls, some of the floor assemblies, some of the trusses, whatever is applicable to your build. We'll start pre-manufacturing that. So by the time your permit's awarded, we usually have a lot of the shell already in production, if not complete. And then further, by the time you're actually breaking ground, doing your foundations, pouring your slab, waiting for your slab to cure, your shell is done, and it's sitting here in the back of our facility, waiting for mobilization, waiting to be shipped out to your job site. So again, all the steps that I'm consolidating here is obviously resulting in us significantly cutting down on that construction build time, right? Construction after the shell itself, our shells can be erected, it's about 2,000 square feet, can be done in a few days, depending on, whether that's one floor or two. But a standard, let's just call it one story build with our North Star walls can be erected in as quick as a week. And then it goes from there depending on how many levels there are. But the construction after the shell itself is standard, right? You still have your plumbers going out there, you still have your electricians going out there, you still have your mechanical folks for your AC going out there. Where we can help expedite that process too is because we're using a CNC machine and it's all programmed. We can actually program the CNC machine to pre-drill any MEP holes, any conduit holes, anything that needs to pass through our wall cavity can be pre-drilled if that's what the subs want. If they don't, it's easy for them to make those adjustments on site. It's not necessarily that complicated. Because our wall has a cavity, right? So we have the 1/4 inch ballistic panel, then we have the 6 inch C channel, right? So that makes the wall cavity. There's that 6 inch gap in the middle. That's where all your MEPs and your insulation go into before doing your 1/2 inch of sheetrock on the other side, right? So the whole assembly is 6 3/4 of an inch once you're done. But because there's that cavity in the middle, it's easier for MEPs to work. With a concrete block home, normally that's 8 to 10 inches of block, and then you have to frame it out for installation and MEPs. Normally, it's very difficult to run your MEPs through the block for obvious reasons, so they have to frame that out, or they have to do it on interior walls, which can make the MEP process a little bit more complicated. Again, it's what people are used to now, so it doesn't seem like it's complicated, but once they work with our system, they see that there's obviously a quicker way to do that. Construction being 6 months, and then your site turnover, everything I just described, your final checklist, your punch list, your final inspections, getting your CO, and boom, we turn over. That duration is more like 8 months, right? Again, on bigger builds, it's still going to take a little bit longer, but you're definitely gaining a lot of time building with prefabricated systems, as opposed to building traditional stick built on site, which takes a little bit longer and is obviously weather dependent, which is something that I didn't even talk about in my timeline. But there's always construction delays due to the weather. But if everything is prefabricated, those delays are certainly expedited, right? I'm going to talk here a little bit about our manufacturing process. So this slide happens to match what our core competencies are, and those are design, engineer, and manufacture. Those are the three things that we do extremely, extremely well, right? We're also a GC, so we can construct and build, being that fourth tenet of what we can do really, really well. But GC is limited to obviously your local area. So we do everything outside of Southwest Florida. We normally have a builder partner program. If you're interested in the builder partner program, please let me know. We love to partner up with builders and other GCs so we can expand our footprint outside of Southwest Florida. So important to know that GCs we're actually trying to work with, not compete against. But because of the novelty of the system, we wanted to build it ourselves to show that it's feasible, to have something to point to so people could see what it is that we're working on without not just seeing some fancy podcast or presentation, right? It's actually, you can go into some of our job sites and see exactly what I'm talking about. But from the core of why we started the company, again, design, engineer, and manufacture, right? And we talked a little bit about each one of these processes already, but as far as like a more detailed point of view, our state-of-the-art process takes design concept through production in an entirely digital environment, right? So that was the Revit and SolidWorks and CAD files that I was talking about earlier. The engineering piece is important too. We're working in that same digital environment to make sure, once again, we can produce a fully engineered stamp set of plans. And then manufacturing, which we do obviously at our facility with our CNC machines that are not only cutting, they're milling, they're routing, they're pre-drilling. I mean, they're basically short of putting the whole house together, they're doing all the hard work, right? And then just like did you know kind of quick tip here. Large structures are installed on site in a panelized format when using Northstar, whereas modular structures are prefabricated at our facilities and then transported to the job site. So that's an important difference, right? Everybody asks me this sometimes, and it makes sense to talk about this in this slide because it is a manufacturing component. There's two different ways to build with our system. You can either do it as a panelized system, which means I pre-build all your walls, your roofs, and your trusses, and your roof assembly, and your floor assemblies, right? And then I flatbed those out to a job site or ship them out to a job site, and then I erect them on site, right? That's one way to do it. It allows for more design freedom. It does save on shipping costs, but obviously there's the erection process that happens on site that needs to be accounted for, right? Now, a modular system, and maybe you've heard about modular construction, it's becoming more popular now, specifically with wood in some Northeast and Northwest states, even the Midwest as well, where in a factory environment, again, like ours, you can actually pre-build the entire structure. So fun fact, the room that I'm sitting in right now is actually completely modular. We built this all within our factory, and this can be towed up to a flatbed. It could be picked up by a helicopter. It could be shipped anywhere, and it would be completely mobile, right? That's the modular piece of it, is the fact that it can be mobilized, and it's drop it and it's ready to go wherever it goes, right? So for modular construction, normally you have one module or two or three that come together to create a structure. Those are already pre-built in the factory. That would be the difference between prefab and modular. Prefab panelized, I should say. And then what happens actually on the on-site aspect? So after these walls are assembled and ready to be shipped out, when we get to the job site, if we're doing the panelized version of what I just talked about, we use a lull or we use a hydro crane. It really doesn't take a lot. We don't need like one of those crazy big construction high-rise cranes that you see out there. Um, that's how we start panelizing the building. So once that slab is cured, we're connecting the wall panels directly to the slab. There is what we call a lip edge, which is where the ballistic comes over the slab by about anywhere from 3 to 6 inches, depending on the depth of that slab and the foundation. And it provides a weather barrier for water intrusion as well. And then the wall sits directly on the slab, and then we tack on and we weatherproof that connection as well. And then once all those walls are up, if there's a second structure, We could do a couple different things. We could do a rim track and joist system, which is like a frame system for your floor assembly for the second floor. We could do Epicore or hollow core if you guys are familiar with that type of construction, normally seen with condos, which is an actual. The Epicore is a poured slab, is like a 2-inch concrete topping on top of a pan. Epicore is precast extrusions of concrete that are laid and that all come together, and it can be post tension as well or pre tension. So those are different types of floor assemblies that we can put on there, and that all happens within that construction process that we do on site. Another fun fact: Northstar homes are typically erected upon concrete foundations reinforced with composite rebar. And that's something that I haven't really talked about today, but we do use composites in our foundations as well. So where you would see steel rebars, we actually use fiberglass rebars, which are, again, have all the same benefits that I've talked about already. But for the most important part being is that they're not going to rust, they're not going to corrode, and they're not going to spall. Spalling is when the rust makes that rebar expand and it breaks the concrete housing around it, which can create significant foundational issues, right? That doesn't happen with a composite rebar, which is why we use them. And I recommend everybody use them, honestly. Even if you're not building a Northstar home, if you're in the process of building a house right now with traditional materials, talk to your GC about using composite rebar, especially if you live in an area like Florida where our soil is already salinic, right? It would be important for you to remember that, right? And to use a non-corrosive material for what's being exposed to salt water, literally. This slide that I'm going to close out with today is important and is a really, really cool thing, what we consider one of our most major accomplishment in our young life in business as Northstar. Northstar is only 4 years old at the time of this recording. We were incorporated in March of 2020. So, right in the middle of COVID, great time to start a business, but it's been a lifelong project for a lot of the members here. For Paul especially, he's been working at this for the last 30 years of his life, right? So Northstar is that culmination of everything he's been working on. But from a company standpoint, still being as young as we are, we were able to very early on achieve a really strategic and incredible partnership with Owens Corning, which is a publicly traded company. They're one of the biggest glass manufacturers in the world, right? And they do a lot more than just glass. They do our insulation. Their glass is actually in all of our composite material, but we use their insulation. They produce shingles. They do composite lumber, which is used for decking. They do a host of different things. They're one of the most innovative companies from a manufacturing standpoint in America right now. I highly encourage you, if you've never heard of Owens Corning, to Google them right now and just spend some time looking at what they do. They're extremely innovative, so much so that they caught wind of what they were doing. Believe it or not, they found us on LinkedIn. So marketing does work, right? They reached out to Paul, and we started basically a relationship via LinkedIn, which eventually matured into them coming to visit our facilities, which were not even close to what they are today, right? And we decided to formulate a strategic partnership in which they invested in Northstar to help fuel our growth and our innovation and our market reach. More important than the investment was the strategic part of that partnership, right? Because we have access to their science and lab departments, we have access to their engineers, we have access to their brain power, right? They're a huge corporation with extremely intelligent people, so it makes that partnership that much more fruitful when we have somebody as amazing as them to partner up and lean on. So that's something that we're expanding upon every single day. We're tackling new projects together every day. They're our biggest cheerleaders, and obviously we're grateful for the relationship. So that's why I always include this slide in a lot of our presentations to talk about that partnership, because it makes us seem more legitimate, right? And I'm okay with saying that. Having the backing of a Fortune 500 company like Owens Corning makes it more attractive, as an end user or as a business, B2B business partner with us, or a GC or a builder or engineer. It makes it that much more attractive to want to do business with, because you could tell that there's a lot of interest in what we're doing. There's a huge upside to where this can go. So grateful for that partnership. And I think on that note, we can end today's episode. And again, this being part 2 of a 3-part series. Next episode, we will talk about how we compare to traditional materials on a little bit more technical level. So if you are a nerd like me and you like statistics, analysis, and you like to see performance You're gonna love next episode. So stay tuned for that. In the meantime, I want to thank you for watching these episodes. I want to thank you for being a subscriber. What would mean the most to me if you could share, you could like, you can comment on all of our social media platforms, including YouTube, and whichever podcast provider you're listening this to on. Give us a follow, give us a like. Please reach out, please connect. Our lines are open. Our emails are always being monitored. We love to hear from you guys. We love to educate. We love the feedback. And I want to know what you're interested in. So as you provide feedback, think about some other cool guests or some cool things or topics that we can talk about so we can continue to make this podcast everything that it can be. And that's all for today. I want to thank you again. Kyle with Northstar Technologies, the F.O.C podcast. Thanks for joining us. See you next time.